It's good to be talking to you guys, and I know we've all been on different pages and picking up, but I just wanted to, these were the notes we would have given in class. I know I've already given these to you, but I just kind of want to go over it, make sure you guys are understanding the key points of ecology. We will be having a quiz on Thursday that wraps up uh, carrying capacity, populations, and limiting factors. So kind of how grades are going to work, and I will probably put this on the classroom as well. You're going to have 2 grades for each we're kind of chunking these sections, kind of like how we did with the ecology project. So you'll have a grade on a quiz, which we'll do on Thursday, and then I'm going to give you a grade on SIS for your homework. And so all these little homework pieces that you've been doing, I'm going to give you an average score. And so you'll have 2 grades for each section. You'll have a homework score and then your quiz score. And that's kind of what we're going to be doing as we move forward and we learn these different things. So make sure you keep up with the homework. I emailed you guys about who's missing what and just kind of check in and make sure you're keeping up with that. Okay, so populations. Um, Let's get through those. Okay, characteristics. Not sure if the videos, I don't think they hit this very hard, so I definitely make sure you know vocab words. Okay, these are the 3 that we're going to look at. 4, I'm sorry. Geographic distribution, density, growth rate, and population age structure. So the names pretty much tell you what they are. So geographic, you're thinking location. Distribution, this is describing the area where population lives. And that's pretty important. Sometimes it could mean we could just be looking at maybe a forest. Other times we can be looking at the southern part of California, like we see here, killer bees in California. So it's important for ecologists to study this so they know how far species, like what their range is, especially when they're trying to figure out their population. Population density, this is the number of individuals per unit area. So again, it goes back to geographical distribution where they're at. How many are population density is how many there are in that area. Okay, so for example, if we went in the back, like in your forest or in your backyard, there's 10 squirrels per acre. Usually you're going to see a number here when we're looking at density. Okay, here's a bigger scale, and these, like I said, this could be a small scale. This is going to be a bigger scale. So if we're looking at people, how many people per kilometer squared? And this is old numbers, it's 2006, but you can kind of look at the numbers for each area. And again, we can look at big scale, or we can even zoom in even smaller. Okay, population growth. Um, Typically, it's affected by 3 things, and I know this was in the video. Obviously, your population is going to grow. It's going to depend on how many births there are, how many deaths there are, and how many individuals are entering or leaving the population. Okay, so let's put some vocab words to this. Entering or leaving. Immigration with an I is the movement of individuals into the area. So they both start with I's. Immigration, into. Immigration with E, this is the movement of individuals out of the area. Or honestly, I like to say exit since they both start with E's, exiting area. So I know they're both look pretty much the same. You have one with I that's into, one with E that's exit. Okay, so that kind of sums up the first part. Characteristics, make sure you know these vocab words and what they mean. The second part, you learned of types of growth. The first one we have is exponential. This occurs when populations are under ideal conditions and unlimited resources. So, no predators, they have plenty of food, plenty of space. Individuals in these scenarios can reproduce at a constant rate. Okay, exponential growth will not happen forever. So, even though this can happen momentarily, it is not going to happen forever. Natural populations are generally restricted in size due to limiting factors, which I know you guys have been studying those. So an exponential is more of a J-shaped curve, like so. Usually we see it in bacteria. They can reproduce really fast. But eventually, guys, they're going to hit carrying capacity, which we're going to see here in a second. So logistic growth is exponential growth followed by the population leveling off due to limiting factors. All populations will eventually hit limiting factors. It could be natural disasters. It could be, human destruction. It could be space, food. There's a lot of different things that can limit a population. So eventually, more realistic is logistic growth. Okay, this is going to be our S-shaped curve because what happens is populations are going to level off at the carrying capacity, which I know you guys have studied. That's the maximum number of individuals the environment can support at a given time, like so. Now, just because, let's say the carrying capacity is 50,000 individuals, doesn't mean as soon as it hits 50,000, it has to stop. It can pop up. We see a little pop-ups here. But typically, if we start to go above the carrying capacity, they're now going to be fighting for resources, which will bring it back down. And it can also dip way down. Let's say a tornado comes in and wipes tons of them out. But usually limiting factors will, a stable population growth would be if it's around the carrying capacity. Okay, and then let's sum up these limiting factors here. Limiting factors cause the population growth decrease. It's something that's going to affect that population size. There's two types that you guys studied in class, density dependent and density independent. And a lot of people mix these up, so let me help you out here. Think dependent, when you're dependent on something. So this is going to be dependent on the density or the size. So when it gets too big, these are the factors that affect it when the population gets too big. So density dependent, it depends on the population size. So what are some examples? Well, competition, obviously. If there's more species, the more species there are, the more competition there's going to be. Predation. The more predators there are, the more they're going to go after the prey. Parasitism, remember we studied that in the last ecology unit. That's when parasites can attack or get resource. They benefit in the relationship. So it's more likely both of these, parasitism and disease, can actually spread more the more individuals there are. So these are all density dependent. So think of in this, well, and we're actually experiencing this right now with the coronavirus. The more individuals in an area, the more likely it is to spread. So that's why we're quarantined right now. So it's not spreading as likely. Okay, and then independent, it is independent of the density level or the size. Affects all populations in similar ways, regardless of the population size. So some examples. Weather. If it gets really hot and it forms a drought or it's really windy, high temperatures, low temperatures, that can really affect species. Doesn't matter if there's 5 or 500, that weather is going to affect it no matter what the size is. Natural disasters, hurricanes, droughts, tornadoes, all those separate things, earthquakes, they're going to affect the population regardless of the size. Seasonal cycles, when winter comes in and things like that, that can affect it. And the big one is human activity. So when we dam rivers, that can affect a lot of populations, deforestation, all those things. Hurricane Katrina, again, if you look at this, doesn't matter what the size is, it's going to come in and destroy whatever's in the way. So when you're thinking density dependent, think biotic. Remember, that's living factors. Density independent is abiotic, or you can think of humans.